Asif Mirza sir, you are live.
Okay, thank you, Neeraj sir. So, welcome, friend. Wel welcome you all in another lecture of AICD sponsored Prerna scheme. Today, we will discuss under the section irrigation. We will discuss the topic design of weirs on permeable foundation, types of irrigation system, and the irrigation methods. So, friends, myself is Professor Asif Beg, Assistant Professor, Civil Engineering Department, Tulsiramji Gaikwad Patil College of Engineering and Technology, Nagpur, an autonomous institute, and recently accredited with NAC A plus grade. So, friends, in the previous class, we have seen about the irrigation scheme and the hydrology cycles and all the things related with this particular section. And will be the last topic of this particular section. So, in the methods of irrigation, we having first the tank irrigation. So, tank is a reservoir for irrigation, a small lake or pool made by the damming the value of a stream to retain the monsoon rain for later use. It accounts for approximately 3% of net irrigated area in India. So, tank irrigation is popularly in peninsular palliative area where Andhra Pradesh and Tamil Nadu are the leading states. So you can see here that tank irrigation is mostly adopted in the particular region like the Andhra Pradesh. About 29% of the irrigation has been done in Andhra Pradesh through this tank irrigation, and in Tamil Nadu, 23% of the irrigation is done in through this tank irrigation. So Andhra Pradesh and the Tamil Nadu, which are the peninsular area, which is mostly adopted states of this method, tank irrigation. Now, what are the kind of tanks? Okay, so the tanks are of two kinds, that is the system tank and non-system tanks. The canal fed tanks are known as system tanks and which were exclusively under the management of the Public Works Department. So PWD departments handle all these canal fed tanks. Okay, so these are called as the system tanks. The system tanks are fed with water from rivers and runoff through diversion weirs. So feeder canal and surface flow. So these system tanks normally we get the water from the river or from the diversion weirs, and the system tanks are minority of tanks that are supplied from the major storage canals irrigation system or from the perennial rivers. So the rain-fed tanks are known as non-system tanks. Non-system tanks which command area below 40 hectares are coming under the control of Panchayat Union. So you can see here the system tanks are comes under the Public Work Department, PWD department, and under Panchayat Union. These non-system tanks are under command, and these non-system tanks have a small storage capacity. So it is practiced mainly in the peninsular region due to the following reasons. So the undulating relief and hard rock make it difficult to dig canals and wells. There is a little percolation of water due to hard rock structure, and groundwater is not available in the large quantities. Most of the rivers are seasonal. There are many streams which become torrential during the rainy season. So the only way to use this water is to impound it by constructing bunds and building tanks. Also, it is easy to collect rainwater in natural or artificial pits because of the impermeable rocks. Scattered nature of the agricultural fields. So we are having the merits and demerits of for this type of tanks. So in the merits, the most of the tanks are natural and do not involve cost of their construction. Independent sources for in individual farmers or small group of farmers, and this type of tank having the longer lifespan and can be used for fishing also. And in the demerits of this type of tanks, which depends on the rains, and these tanks may dry up during the dry season. Silting of their beds require large area, evaporation losses, and sometimes there might be a need of lift the water to take it to the field. So these are a few demerits over the merits. Now we will talk on the well. And well, most of the time it is being used as a tube well, and a well is a hole dug in the ground to obtain the subsoil water. An ordinary well is about 3 to 5 meter deep, but deeper wells up to 15 meter are also dug. This method of irrigation has been used in India from the immemorial, immemorial various methods are used to lift the groundwater from the well. Some of the widely used methods are the Persian wheel, rate, charas or mott, and Dhingley lever, etc. A tube well is a deeper well, generally over 15-meter deep, from which water is lifted with the help of pumping set operated by an electric motor or a diesel engine. Well irrigation. So we will talk on these well irrigations. Well irrigation is gradually giving way to energized tube wells, but there are many wells still in use where electricity is not available or the farmers are too poor to afford diesel oil. So many of the farmer who belongs to the poor background or the economical background is very weak, or they belongs to the very uh, what we can say the rural area that cannot be adopted any mechanical or the electrical motor. So the water is raised in the well irrigation by the manually only, and this method of irrigation is popular in those areas where sufficient sweet groundwater is available. It is particularly suitable in areas with permeable rock structure, which allows accumulation of groundwater through percolation. Now, therefore, wells are seen more in areas with alluvial soil, regur soil, etc., and less seen in rocky terrain or mountainous region. These area includes a large part of the Great Northern Plains, the deltaic region of the Mahanadi, the Godavari, the Krishna, and the Kaveri part of the Narmada and the Tapi. And the Tabi Valley and the weathered layers of the Deccan Trap and crystalline rocks and the sedimentary zones of the peninsula. However, the greater part of the peninsular India is not suitable for well irrigation due to the rocky structure, uneven surface, and lack of underground water. Large dry tracts of Rajasthan, the adjoining part of the Punjab, Haryana, and Gujarat, and some part of the UP have UP have brackish groundwater which is not fit for irrigation and human consumption, and hence unsuitable for well irrigation. Now, at present, irrigation from wells and tube wells account for more than 60% of the net irrigated area in the country. Now, UP has the largest area under well irrigation, which accounts for 28% of the well irrigated area of the country. UP, Rajasthan, Punjab, Madhya Pradesh, Gujarat, Bihar, and Andhra Pradesh account for about three-fourths of the total well irrigated area. Now, what are the merits of this well irrigation? This well irrigation is simplest and the cheapest one, in which it is an independent source of irrigation and can be used as and when the necessity arises. Canal irrigation, on the other hand, is controlled by other agencies and cannot be used at will. Some groundwater salts are useful for crops, does not lead the salinization and flooding problems. There is a limit to the extent of canal irrigation beyond the tail end of the canal, while a well can be dug at any convenient place. Now, what are the demerits of this well irrigation? This is only limited area can be irrigated. Normally, a well can irrigate 1 to 8 hectares of the land, not suitably for dry region, and overuse may lead to the lowering of water table. Now, moving towards this irrigation method, so in the flow chart or the flow diagram, you can see here what are the various types of irrigation methods in which the surface irrigation is there, surface irrigation is there, sprinkler irrigation is there, and also drip irrigation. In surface and sprinkler irrigation, these are classified again. Sprinkler irrigation is classified into two, that is the rotating head and the perforated pipe. Now, surface irrigation again classified into three: border surface irrigation, check basin surface irrigation, furrow surface irrigation. Now, border surface irrigation again classified into two: straight and contour irrigation, and check basin surface irrigation is classified into three, that is rectangular, contour, and the ring check basin surface irrigation. Now, the third classification of surface irrigation, that is furrow. So, furrow surface irrigation method again classified into two, that is the deep furrow and the corrugation. Deep furrow again it is classified into two: straight and contour. And corrugation under this furrow classification, it is again divided into two: straight and contour. And under this straight irrigation is divided into two: level and graded. So this is how we can classify the various methods of irrigation in through this flow chart. Now we will see one by one what is meant by the surface irrigation. So surface irrigation is defined as the group of application techniques where water is applied and distributed over the soil surface by gravity. It is by far the most common form of the irrigation throughout the world and has been practiced in many years, virtually uh, virtually unchanged for thousands of years. Now, surface irrigation, these are four variations under the methods. Surface irrigation is again divided into four, that is flooding, bed or the border method, which is also called as saras and flat beds, basin method, ring and basin, and finally the furrow method, which is also called as the rides and furrows, broad ridges or the raised bed. Now, flooding. It consists of opening a water channel in a plot or field so that water can flow freely in all directions and cover the surface of the land in a continuous sheet. Now, it is the most inefficient method of irrigation as only about 20% of the water is actually used by plants. The raised wing is lost as a runoff, seepage, and evaporation. Water distribution is very uneven and crop growth is not uniform. It is suitable for uneven land where the cost of the leveling is high and where a cheap and abundant supply of water is available. Now it is unsuitable for crops that are sensitive to waterlogging, and the method suitable where broadcast crops, particularly pastures, alfalfa, peas, and small grains are produced. Now, what are the adaptations for this method? An abundant supply of water, close growing crops, soil that do not erode easily, soil that is permeable, irregular topography, and the area where water is cheap. Now, what are the advantages of this method? It can be used on shallow soil, can be employed where expense of laboring is great, installation and operation costs are low, system is not damaged by livestock and it does not interfere with use of farm implements. Now, as we're having the advantage of this method, there are few disadvantages as well. And in this excessive loss of water by runoff and the deep percolation, in which the excessive soil erosion on step land and fertilizer and FYM are eroded from the soil. Now, again, you can see in the diagram itself, this is the in this diagram it is shown how this method is being adopted on the land, and the laterals are provided on the field at a distance of 15 to 45 meter, and this is the water is sprinkler on the ground, and the irrigation has been done. Okay, now the bed or the border methods. So Sara and flat beds or check basin. In this method, the field is leveled and divided into small beds surrounded by bunds of 15 to 30 centimeter high. Small irrigation channels are provided between two adjacent rows of beds. The length of the beds varies from 30 meter for loamy soil to 90 meters for clay soils. The width is so adjusted as to permit the water to flow evenly and wet the land uniformly. For high value crops, the beds may be still smaller, especially where water is costly and not very abundant. This method is adaptable to most soil texture except sandy soil and is suitable for high value crops. It requires level land. So as you can see here, this is the method which is very much similar to the previous method we have seen, but in this method we can cover the more area and we can do the well irrigation by adopting this type of method, and it is more efficient in the case of if you compare the previous method. So this is more efficient in the use of water and ensures its uniform application. It is suitable for crops plant in lines or sown by broadcast. Now, through the initial cost of high requires less labor and low maintenance cost. This may also be called a sort of Sara method followed locally in Maharashtra, but the Saras to be formed in this method are much longer than broader. Now, the types of border irrigation having again these having the two methods. First one is the straight border and another one is the contour border. So in straight border are formed, these borders are formed along the general slope of the field. These are preferred when field can be leveled or be given a gentle slope economically. Now, in the figure, you can see here the border strips are provided here with having the uniform slope, and this vertical line is nothing but the side ridges, and this inclined line is showing the cross ridge. Okay, so you can see in the diagram the uniform slope is provided. Okay, now this is the progressive water sheet on the ground through provided through the siphon tubes. Okay, now moving toward the next method, that is the contour border. So these are the formed across the general slope of the field and are preferred when land slopes exceeds the safe limits. Now, as fields are undulating and require a lot of earthwork or to level, economical leveling is not possible. Design criteria for both are not different. And what are the adaptations for why on which condition this method is to be adopted, that we will see. Now, a large supply of water. When the large supply of water, this method can be adopted. Most soil texture, including sandy loams and clays, soil at least 90 centimeter deep and suitable for close growing crops. So these are the adaptations points on the basis of which we have to adopt this method. Now, moving toward the next method, that is the advantages. So, fairly large supply of water is needed. Land must be level, suited only to soil that do not readily disperse, and drainage must be provided. So, you can see here this is the advanced sheet of the water on the land. These are the bunds are provided, and this is the field channel. So, through this field channel, this water is provided to the land. Uh, and this is the slope provided, uniform slope provided on the ground. So this is what the contour method is being adopted on the leveled ground. Okay, now moving toward the basin irrigation. So this method is suitable for orchards and other high value crops where the size of the plot to be irrigated is small. Now, the basin may be square, rectangular, or in circular shape. Variation in this method with ring and basin is commonly used for irrigating fruit trees. A small bunch of 15 to 22 centimeter high is formed around the stump of tree at a distance of about 30 to 60 centimeter to keep soil dry. Now, the height of the outer bund varies depending upon the depth of the water proposed to retain. Basin irrigation also requires level land and not suitable for all types of soil. It is also efficient in the use of water, but its initial cost is high. Now, there are many variations in its use, but all involve dividing the field into smaller unit area so that each has a nearly level surface. Bunds or ridges are constructed around the areas forming basin within which the irrigation water can be controlled. Check basin types may be rectangular, contour, and the ring basins. Now, what are the type of check basin? So, first is the base, which is based on the size and shape. So the size of check basin may vary from 1 meter square used for growing vegetables and other intensive cultivation to as large as 1 or 2 hectares or more used for growing rice under wet land condition, while the following points need to be considered. So in case of rectangular the shape, the basin are rectangular in shape when the land can be graded economically into nearly level fields. Now, when the contour looking into the level of that ground, the ridges follows the contour of the land surface, and the contour ridges are connected by cross ridges at interval when there is rolling topography. The vertical interval between contour ridges usually varies from 6 to 12 centimeter in case of upland irrigated crops like wheat, and 15 to 30 centimeter in case of lowland irrigated crops like rice. Now, where to be adopted this method, that we will see. So how if when the most soil is texture, high value crops, smooth topography, and the high water value per hectare. So these are the criteria or the condition when we have to adopt this method. Now, what are the advantages of this method? So this is varying supply of water, no water loss by runoff, rapid irrigation possible, and no loss of fertilizer and organic minerals, and it is very much satisfactory. Now, looking into the advantages, we also having some disadvantages for this method. If land is not level, initial cost may be high. So to make this, to make the land level, we have to use many equipment. We have to use the manpower, we have to use the machine power, and ultimately the cost of this leveling will be increased. So initial cost will be increased if the land is not leveled. Now, suitable it is suitable for mainly for orchids, rice, and the jutes, etc. Except rice, not suitable for soil that disperse easily and readily from the crust. So this is what in figure it is shown that this is the rectangular shape of basins are provided, and this is the supply dish through which the water is supplied on the channels, and through these siphon pipes the water is provided into that particular rectangular portion. So this is how this method is being adopted on the level ground. Now moving toward the next method, that is furrow method. So in this method, irrigation water is useful for row crops. Narrow channels are dug at regular intervals. Water from the main supply is allowed to enter these small channels or furrows. So water from the furrows infiltration infiltrates into soil and spread laterally to saturate the root zone of the crops. It is suitable for row crops like potatoes, sugarcane, tobacco, maize, groundnut, cotton, jowar, etc. Now, row crops such as potatoes, cotton, sugarcane, vegetables, etc., can be irrigated by furrow methods. Water is allowed to flow in furrow opened in crops row. It is suitable for slopy land where the furrow are made along contours. The length of the furrow is determined mostly by soil permeability. Now it varies from 3 to 6 meters. It in sandy and clay loams. The length is shorter than in clay and clay loams. Water does not come in contact with the plant stems. Now there is a great economy in use of water. Sometimes even in furrow irrigation, the field is divided into beds having alternate rides and furrow. On slopes of 1 to 3%, furrow irrigation with straight furrows is quite successful. Now, but on steeper slopes, contour furrows not only check erosion but ensure uniform water penetration. Now, irrigation furrows may be classified into two general types based on their alignment. So they are straight furrow and the contour furrow. Now, straight furrow is having they are best suited to sites where the land slope does not exceed 0.75%. In areas of intense rainfall, however, the furrow grades should not exceed 0.5% so as to minimize the erosion hazards. Now, the range in furrow slopes for efficient irrigation in different soil types are the same as those recommended for borders. Now, control furrows. Now, these contour furrows, which carries water across a sloping field rather than the slope, contour furrows are curved to fit the topography of the land. Now, contour furrow method can be successfully used in nearly all irrigable soils. The limitation of straight furrows are overcome by contouring the include sloping lands. Light soil can be irrigated successfully across slopes up to 5%. Now, what are the adaptations for this method? The contour furrow may be adopted when the medium and the fine textured soil is available, variable water supply is available, and the farms with only small amount of equipment. Now, what are the advantages of this method? Is it is very high water efficient, it can be used in any row crops, so and it is a relatively easy installation and not expensive to maintain. And the final advantages of this is the it can be adapted to the most of the soil. Now, what are the disadvantages of this method? Is it required of skilled labor is more in more quantity, hazard to operation of machinery, and the drainage must be provided. Now, this is what this method is been adopted on the field. So this is the main ditch line in which this main ditch line is provided water through these furrows, and this is the plants in the rows on which this water is provided through these furrows. Okay, now moving toward the next one, that is the contour farming. Now, contour farming involves plugging, ploughing, planting, and weeding along the contour. So that is across the slope rather than up and down. Now, contour lines are lines that run across a hill, and which is the line stays at the same height and does not run uphill or the downhill. As contour lines travel across a hillside, they will be close together on the steeper parts of the hill and further adopted on the gentle parts of the slopes. Now, this contour farming experiments show that contour farming alone can reduce soil erosion by as much as 50% on the moderate slopes. However, for slopes steeper than 10%, other measures should be combined with contour farming to enhance its effectiveness. Now, what are the benefits of this method? Is this contouring can reduce soil erosion by as much as 50% from up and downhill farming, and by reducing sediment and runoff and increasing water infiltration. Now, contouring promotes better water quality. It gives 10 to 15% of additional yield value. Now, what is the criteria for surface irrigation method selection that we will see? So the deciding factor for suitability of any surface irrigation method are natural conditions like slope or the soil type. Now the type of crops, required depth of the application, level of technology, previous experiences with irrigation and which require the labor input. Now moreover, the irrigation system for field must be compatible with the existing farming operation such as land preparation, cultivation and harvesting practices. Now, the following outline lists a number of factors of the environment which will have a bearing on the evaluation of irrigation system, alternates, and the selection of the particular system. Not all points will be equally significant in each case, but the outline can serve as useful checklist to prevent overlooking important factors. Now, what are the physical factors for this? So, crops and the cultural practices are of prime importance while the selecting an irrigation system. Now, proper knowledge of agronomic practices and irrigation intervals is necessary for proper use of irrigation water and to increase water use efficiency. The following physical factors need to be given due consideration. Now, what are the crop parameters? So, this is the tolerance of the crop to soil salinity during development and maturation, magnitude and temporal distribution of water necessary for maximum production, economic value of crops. Now, soil parameters, so texture and structure, infiltration rate and erosion potential, salinity and internal drainage, bearing strength. Now, sandy soil have a low water storage capacity and a high infiltration rate. Under these circumstances, sprinkler or drip irrigation are more suitable than surface irrigation. Clay soil with low infiltration rates are ideally suited to surface irrigation. Now, high intake characteristics require high flow rate to achieve the same uniformity and efficiency. Crusting of soil and its effects on infiltration, reclamation and soil leaching, basin irrigation, spatial variability, field topography. So, uniform mild slope facilitate surface irrigation. Location and relative elevation of water source, water diversion pumping acreage in each field. Location of roads, natural gas lines, electricity lines, water lines, and other obstructions. Now, shape of the field, non-rectangular shapes are more difficult to design for field slope, that is stiffness and the regularity. Now, furrow and borders, that is 2 to 6% max to max. Now, moving towards the next, that is the climate and the weather condition. Now, under very windy condition, drip or the surface irrigation method are preferred. Scalding, the disruption or oxygen carbon dioxide exchange between the atmosphere and the roots, and the effect of water temperature on the crop at different stage of growth risk in basin irrigation. Now, irrigation with cold water early in the spring can be delay growth, whereas in the hot period of the summer, it can cool the environment, both of which can be beneficial or detrimental in some cases. Now, water supply. So, the following parameters are important in case of water supply. So, source and the delivery schedule, water quantity available and the reliability, water quality, water table in case of groundwater source, availability and reliability of electricity, availability and reliability of energy for pumping of water is a machine is much importance. Now, what are the economic consideration? This is the one of the main important factor which we have to consider. So the following points need to be considered while selecting irrigation alternatives, and the capital in investment required and recurring cost, credit availability and interest rate, life of irrigation system, efficiency and cost economics, social consideration. So this is also we have to consider the education and skill of common farmers and labor available for handling the irrigation system, the social understanding of handling of cooperative activities and sharing of water resources, legal and political consideration, local cooperation and support, availability and skill of labor and level of automatic control. Now, suitability and limitation of surface irrigation method. So, some form of surface irrigation is adaptable to almost any vegetable crop. Basin and border strip irrigation have been successfully used on wide variety of crops. Furrow irrigation is less well adapted to field crops if the cultural practices require travel across the furrows. However, it is widely used in vegetable like potato. Basin and border strip irrigation flood the soil surface and will cause some soil to form a crust, which may inhibit the sprouting of seeds. Now, surface irrigation systems perform better when soil are uniform. Since the soil controls the intake of water for basin irrigation, basin size should be appropriate for soil texture and infiltration rate. Basin length should be limited to 100 meter on very coarse texture soil but may reach 400 meter on other soil. Furrow irrigation is possible with all type of soils, but extremely high or low intake rate soil require excessive labor or the capital cost adjustment that are seldom economical. A major cost in surface irrigation is that of land grading or leveling. The cost is directly related to the volume of the earth that must be moved, the area to be finished, and the length and the size of farm canals. Now, moving toward the next method, that is the micro irrigation method. Now, in case of micro irrigation method, these are precision irrigation method of irrigation which very high irrigation water efficiency. In many parts of the country, there is decline of irrigation water, and conventional methods are having low water use efficiency. To surmount the problem, micro irrigation method has recently been introduced in Indian agriculture. These methods save a substantial amount of water and helps increasing crop productivity, particularly valuable cash crops like vegetables. Now, the research results have confirmed a substantial saving of water ranging between 40 to 80%, and there are reports of 2 times yield increase for different crops by using micro irrigation. Now, there are two main micro irrigation systems are advantages of micro irrigation. First one is water saving possibility of using saline water, efficient and economic use of fertilizers, easy installation, flexibility in operation, suitable for all the types of land terrain, also suitable to wasteland. Now it enhanced plants growth and yield and uniform and better quality of production, less weed growth, labor saving, no soil erosion, saves land as no burns etc are required, minimum disease and the pest infestation. Now, moving toward the next one, that is the sprinkler irrigation. So, in sprinkler irrigation, water is delivered through a pressurized pump network to sprinkler nozzle or jets, which spray the water into the air. The fall to the soil in any artificial rain, the basin or the basic component of any sprinkler system are a water source, a pump to pressurize the water, a pipe network to distribute the water throughout the field, sprinkler to spray the water over the ground, and valves to control the flow of water. The sprinkler, when properly spaced, give a relatively uniform application of water over the irrigated area. Now, this is the system is provided for a particular sprinkler irrigation method. Now, these are the component of sprinkler irrigation method. You can see here in the diagram. These are the pipe, riser pipe, where the sprinkler heads are attached to this riser pipe. This is attached on sub or the lateral pipe. Okay, and this is the main line which is attached to the pump, and pump is attached to this what we can say the water resource. Okay, so this is how we have to uh, adopt this sprinkler irrigation system. Now, sprinkler system are usually uh, usually there are some explanation uh, designed to be usually designed to be what we can say designed to apply water at a lower rate than the soil infiltration rate, so that the amount of water infiltrated and at any point depend upon the application rate and time of application, but not the soil infiltration rate. Now, general classification of sprinkler system are classified into the following two major types on the basis of arrangement for spring irrigation water: rotating head or the perforated pipe system. Rotating head is also called as revolving sprinkler system. Now, component of sprinkler irrigation are: pump unit is required, okay, sub mains or the laterals or the tubbings mains are required, couplers are required, sprinkler head are required, and other accessories such as the valves, vanes, plugs, and the risers. Now, suitability and the limitation for this sprinkler irrigation is: with regards to crops, soil, and the topography, nearly all crops can be irrigated with some type of sprinkler system through the characteristics of the crop, especially the height must be considered in system selection. Sprinkler are sometimes used to uh, germinate seeds and establish ground cover for crops like lettuce, alfalfa, and salt. The light frequent application that are desirable for this purpose are easily achieved with some sprinkler system. Sprinklers are applicable to soil that are too shallow to permit surface shaping or too variable for efficient surface irrigation. Now, in general, sprinklers can be used on any topography that can be formed. Land leveling is not normally required. With regards to labor and energy consideration, it has been observed that labor requirements vary depending on the degree of automation and mechanization of the equipment used. Now, hand move system require the least degree of skill but the greatest amount of labor. Now, what are the advantages of sprinkler irrigation? The following are the advantages of sprinkler irrigation, which are the elimination of the channels for conveyance, therefore non-conveyance loss, suitable to all type of soil except heavy clay, suitable for irrigation crops where the plant population per unit area is very high. It is most suitable for oil seeds and other cereal and vegetable crops. Now, water saving, closer control of water application, convenient for giving light and frequent irrigation and higher water application efficiency. Increase in yield, mobility of system may also be used for undulation areas, saves lands as no bunds are required. Areas located at the higher elevation than the source can be irrigated. Now, influence which it affects the greater conductive microclimates, and it is possibly of using soluble fertilizer and the chemicals. Now, which having the less problem of the clogging of sprinkler nozzle due to the sediment laden water. Now, what is the capacity of the sprinkler system? So this is the equation is given for this calculation of the sprinkler system, and the numerical which is based on this equation can be asked in the gate examination. So the equation, that is the capacity Q, which is nothing but the discharge capacity of the pump liter per second, is equals to 2780 into A into D divided by F into H into E, where A is nothing but the area to be irrigated in hectares, D is nothing but the net depth of the water application in centimeter, F is the number of days allowed for the completion of the one irrigation. H is nothing but the number of actual operation hours per day, and E water application efficiency in percent. Now moving to the next method, that is the drip irrigation. Now drip irrigation, also known as the trickle irrigation or the micro irrigation, is an irrigation method which minimizes the use of water and fertilizer by allowing water to drip slowly to the roots of the plants, either onto the soil surface or directly onto the root zone through a network of valves, pipes, tubing, and the emitters. Now it is becoming popular for row crops irrigation. This system is used in place of water scarcity as it minimizes conventional losses such as deep percolation, evaporation, and runoff, or recycled water is used for irrigation. Small diameter plastic pipes fitted with emitters or the dippers at selected spacing to deliver the required quantity of water are used. Drip irrigation may also use devices called micro spray heads, which spray water in a small area instead of dripping emitters. Subsurface drip irrigation uses permanently or temporarily buried drip per line or drip tape located at or below the plant roots. Pump and valves may be manually or automatically operated by a controller. Drip irrigation is the slow, frequent application of water to the soil through emitters placed along a water delivery line. Now, the term drip irrigation is general and includes several more specific methods like drip irrigation applies the water through small emitters to the soil surface, usually at or near the plant to be irrigated. So, subsurface irrigation is the application of water below the soil surface. Emitter discharge rate for drip and subsurface irrigation are generally less than 12 liter per hour. Now, this is for the arrangement for the drip irrigation, and these are the components shown here for the drip irrigation. So, which is also listed here. So, you can see here this is the sand separator hydrocyclone here. This is a sedimentation tank. The air gauge is provided. The water is provided through this drip line through these main lines. Okay, this is the fertilizer line and this is the irrigated area. Now, what are the components? So, the pump or the pressurized water source, water filter is required. So, in which the filtration system, sand separator, cyclone, screen filter, media filters are all are adopted or the used. So, fertigation system, backwash controller, main line, hand operated electric or the hydraulic control valves and the safety valves, small diameter polytube, poly fitting and the accessories, emitting devices at plants are used in the drip irrigation. Now, what are the suitability and its limitation? Now, from standpoint of crops, soil and the topography drip irrigation is best suited for tree, vine, and row crops. A lot of research work has been conducted to establish the suitability of drip irrigation and for different vegetables crops too. So drip irrigation has been found suitable both for field vegetables crops and also under covered cultivation practices. Now, with respect to water quality and the quality, drip irrigation uses a slower rate of water application over a longer period of time than other irrigation method. The most economical design would have water flowing into the farm area throughout most of the day, every day during peak use of trades. If water is not available on a continuous basis on farm, water storage may be necessary. Now, through a form of pressurized irrigation, drip is a low pressure, low flow rate method. These conditions require small flow channel opening in the emission devices, which are prone to plugging. High efficiencies are USP of drip irrigation system. Properly design and maintain drip system are capable of high efficiencies. Design efficiencies should be on the order of 90 to 95%. Now, labor and the energy consideration are very important consideration in drip irrigation system. Due to their low flow characteristics, drip irrigation system usually have few subunits and are designed for long irrigation times. Now, drip irrigation system generally use less energy than other forms of pressurized irrigation system. The emission devices usually operates at pressure ranging from 5 to 25 psi. Additional pressure is required to compensate for pressure losses through the control heads, filter and control valves, and the pipe network. Economic factor need special attention in case of drip irrigation system as initial cost and operational cost is reasonably high. Now, drip system cost can vary greatly depending on crops and type of hose employed. Now, what are the advantages of this? Are the advantages of drip irrigation are minimized fertilizer nutrient loss due to the localized application and reduced leaching allows safe use of the recycled water. High water distribution efficiency, moisture within the root zone can be maintained at field capacity. Leveling of the field not necessary. Soil type plays less important role in frequency of the irrigation, minimize soil erosion. Highly uniform distribution of water controlled by output of each nozzle. Low labor cost, early maturity and good harvest. Foliage remains dry, thus reducing the risk of the disease. Now, when we see the performance indicator, conventional irrigation method and the drip irrigation are divided and classified. So that we will skip because we have to cover much more topics in particular lecture. Okay, so now moving toward the next topic, that is the fertigation. What is mean by the fertigation? So fertigation is the process of application of water, soluble soil, solid fertilizer or liquid fertilizers through drip irrigation system. Now, through fertigation, nutrients are applied directly into the weighted volume of soil immediately below the emitter, where root activity is concentrated. Now, fertigation is practiced only in drip irrigation system. However, fertilizer solution can be added with sprinkler irrigation system also. So this is what the component of the fertigation are here. So this is the water supply. This is the centrifugal pump provided at this point. Now this is the discharge pipe, and through this discharge pipe, the water is provided to this tank for the fertilizer solution. And this is continued to the sprinkler. Now when looking into the component of the fertigation, the main component of the fertigation is drip irrigation system. The main components are venturi pump, that is the injector, fertilizers tank with flow bypass, pressure bypass tank, and injection pump. Now, what are the advantages of fertigation? So, the fertilizer solution is distributed evenly in the irrigation network with the same uniformity as the irrigation water. Now, the availability of the nutrients, including micronutrients, is high. Therefore, the efficiency is very good. The fertilizer system can also be used for other activities such as incorporating acid to flush the drip system. It eliminates the work of spreading fertilizer. Manual spreading of fertilizer causes soil compaction and may damage the growing crops. Now, fertilizer placement is exactly to the root zone of the plants and can be uniformly applied through drip irrigation system. All types of nutrients can be given simultaneously. Lower doses of fertilizer could be applied daily or weekly. That is a large number of split application to avoid leaching and fixation in soil. Now, some liquid fertilizers are free of sodium and the chloride salts, so these are not harmful to the soil. Now, the optimum production is light soil is possible. Spraying with a liquid or the fertilizer is possible. Liquid fertilizer are immediately available to plants. Fertilizer use efficiency can be increased by 25 to 30% over the traditional method of fertilizer application. It decreases labor and the energy cost. The quality and the quantity of crop production can be improved. Now, these are the few are the limitations for this method. The fertigation system also has some limitations, which is the main one is it is the danger of poisoning people who drink the irrigation water, particularly laborers, those who work on the farm. It is therefore necessary to warn the people in the field about drinking water separately and put up warning signs. The reverse flow of the water mixed with fertilizer must be prevented. Now, toxicity and the contamination. So, care must be taken whenever fertilizer solution is introduced into the water supply system. Now, what is the suitability for this? Slowly, water-soluble fertilizers such as super phosphates or the calcium ammonium phosphates is not suitable. This method is suitable for liquid fertilizer or those that are readily soluble in water. Now, we will looking into the corrosion. So, the metallic parts of the equipment are highly prone to corrosion. Sensitive parts of the equipment must be made out of the corrosion resistant material, and the extra care should be taken while filling the tanks. Now, we will skip this keywords point of this. Now, moving toward the water distribution system. So, the irrigation water may be applied to crop either by flooding the field or by applying the water beneath the soil surface, by spraying it under the pressure, or by applying it on the in the drops. So, selection of the suitable method from among these methods depend on the topography, soil condition, land preparation, type of crops, and its value, available water supply, and the other factors. So, of consideration of all these factors, we have to apply the water. So, water application methods are the surface, subsurface, sprinkler, and drip. And again, surface method is classified into three. That is the check basin, furrow, and the border. Now, we having the check basin irrigation. So check basin irrigation we can see here. This is what the check are provided at this point on the ground field. This is the field channel. This is the check here provided, and this is the water flow showing in this. Okay, so this is what the check basin and the circular basin are provided on the field. Now, what is the method to apply the irrigation water to check basin? So you can see here in the direct method, irrigation water is led directly from the field channel into the basin through siphons or bunch breaks. And basin A, you can see here, is irrigated first, and then basin B, and so on. We have to be irrigated. So this method can be used for most crop types and also be suitable for the most type of the soil. Now this is the very direct method. Now moving toward the next, that is the cascade method. So in this method, namely cascade method is suitable for sloping land where the terrace are used. In this method, the irrigation water is supplied to the highest terrace and then allowed to flow to a lower terrace and so on. So in figure, water is supplied to a terrace A1 until lowest terrace A3 is filled. So the supply to A1 is then closed and irrigated. Water is diverted to the terrace B1 until B1, B2, and B3 are filled and so on. So this is the method of for the cascade method. Now moving toward the next, that is the furrow irrigation. Now this is what similar, very much similar to the method which we have seen in the irrigation. Okay, so that we will skip. And at this stage, now we can say we have understood about the various methods of the irrigation systems, and in what condition we have to adopt this kind of irrigation methods. Okay, so at this moment, I think we will stop here, and in next class, uh, we will have in next 5 to 10 minutes we will have some questions on these what we can say irrigation topic. Okay, so let's begin with the few question which is being asked in the gate examination about this irrigation method, irrigation topic. Okay, now in the previous parts also we have seen the various question on the hydrology as well. In the same PDF file, we're having the questions about this irrigation methods. So these are the questions which is asked in the gate examination about the irrigation. So you can see here this question is asked on the delta. An agricultural land of 437 hectare is to be irrigated for a particular crop. The base period of the crop is 90 days and the total depth of the water required by the crop is 105 centimeter. If a rainfall of a 50 centimeter occurs during the base period, the duty of the irrigation water is, so duty of the irrigation water, the duty we have to calculate as 8.64 into 90 divided by 105 minus 50 divided by 100. So total 864 hectare per cubic meter means the option number D will be the right answer for the given question. Now, this question is asked again in the gate examination for 2 marks. Now, so we having the questions on duty and delta. So wheat crops require 55 centimeter of water during 120 days of base period. The total rainfall during the period is 100 mm. Assume the irrigation efficiency to be 60%. The area in hectare of the land which can be irrigated with a canal flow of 0.01 meter cube per second is 13.82, 18.85, 23.04, and 30.40. Now, using the equation of delta, we are having the area of duty is 2304 hectare per cubics. By using this area, A is equals to D into Q. By putting all the value, we will get the value as 13.82. So option number A will be the right answer for this question. Now, the next question is about the transplantation of rice requires 10 days and total depth of the water required during the transplantation is 48 centimeter. So during this transplantation, there is an effective rainfall useful for irrigation of 8 centimeter. The duty of irrigation water in hectare per centimeter cubic is by using the equation of duty, we having 216 hectare per cubic is the answer. So option number B will be the right answer. So delta and duty we are having equation. So uh, what will be the base period B in days are related of. So option number A, this will be the right answer. So delta is equals to 864 uh, days divided by period, base period divided by duty. So option number A will be the right answer for this. So sometimes the question may be asked to solve the duty or the delta. Sometimes the equation may be asked in the question. Okay. So at this moment, we will stop here, and I hope you understand all these irrigation methods, system of irrigation, and we have also solved various questions under this irrigation lecture of irrigation systems. Okay, so uh, we are stopping here. Mm, we have completed this section. So thank you very much.